Hello, welcome to the tutorial video on integrating by partial fraction. Okay, so in this video we'll go through how to do some fractional polynomial integrals, okay, and get a result in partial fraction. Then we can use basic definitions that we know to integrate it. Okay, so in our first video of integration we learned that the integral of 1 over x dx is equal to ln of x plus c. Okay, so always when I write a basic definition, I'm expecting you to understand it. Just write it down, because those are the ideas we'll be using in doing the difficult calculus you think. Okay, so most of the difficult differentiation that you think they are difficult, or integration that you think they are difficult, they are mostly from the basic definitions. Okay, so I'll urge you to always try to get a basic before you start doing things. Okay, all right, so like this, if I have it in a different variable, okay, the u as well, this should give me ln of u, okay, plus c. All right, and these u's will come into play when you are dealing with integration by substitution. Okay, so let's go through this and know how to go about this. But first of all, try to record this. Okay, now I have this integral to compute. How do I start? This side, okay, this one is the same as saying the integral of 1 over x into x squared plus 5, okay, dx. This is the same. All right, but now how do I start this? Because I can't do this just manually. We don't know how to differentiate, integrate this. So what you do is try to convert the whole of this to a partial fraction. That will help you to solve. All right, so now let's start. Okay, now I just convert this fraction side, x squared plus 5 equals what? A over x plus bx plus c over x squared plus 5. All right, I'm kinda sure that by now I'm clearing this part. Okay, we need just only one definition. I'm kinda sure that by now you know how to deal with partial fractions. Okay, so if you don't know how to deal with partial fractions, please kindly try to remind yourself of that. Okay, one thing about mathematics that I always tell my students is that always make sure your basics are with you forever, because whatever question you are solving, wherever you go, it will demand it. Okay, so don't learn and forget. Try to learn to have those things stick to your hand. Okay, so let's start with this idea. From our basic level, they will tell us that, oh, just equate the powers, the denominators after solving the fraction on the right side. Okay, so solving this, you know how to do it. Just a times the denominator of the other one plus 5, then plus x times this one plus c, all over x into x squared plus 5. Now it's not just equating the power. It's just that I'm trying to say that there is something over this and it's equal to that. Then it means once the denominators are the same, it means that the numerators are also the same. That's why we equate them. But in basic level, they just tell you do this, do that, without explaining to you. Okay, if I tell you that a over 2 is the same as, let's say, 8 over 2, then it means that automatically a is equal to 8, because the denominators are the same. I hope you understand. That is why we do the equation here. Okay, so let's clean some parts and get more space and work. So now we are saying that from what we did earlier, 1 should be equal to a into x squared plus 5, then plus either way x times bx plus c. Okay, so solving this, you know how we go about it. If I set x equals 0 in the first place, I'll get 1, just putting x equals 0 in place of wherever you see x. I'll get 5a, because I'll get a times 0 squared plus 5, that will be 8 times 5. Okay, that will be 5a. Then plus 0 times the whole of this side, and that will be 0. So it means we'll get 1 equals 5a. Okay, this implies that making a the subject, we get a is equal to what? 1 over 5. Okay, so now let me write a here. A is equal to 1 over 5. So what is our b and c? Okay, let's try to do something here. Okay, mind you, the reason why we first set x equals 0 is that we saw that after putting x equals 0, it can eliminate both b and c, and we'll be left with a. Okay, so if you think there is a way that we can put x equals something to eliminate a and something else to be left with b, we will do that. But looking at this case, there is no way we can do it. So what you do is just expand the right side. Okay, and we get as squared plus 5a plus bs squared plus cx. Okay, now we try to group like terms. So a plus what, you come to this side, b all square, you just factor s square out from that. Okay, and that's what we get, and then plus cx plus what, 5a. Now we are saying that the whole of this, the left side, this one, should be equal to the right side, this. Okay, so it means that if the right side is a polynomial, if the right side is a polynomial like this, then the degrees, the coefficient of the degrees of the polynomial at the right should be equal to the coefficient of the degrees at the left. Okay, but when you look at the degree at the right, let me erase some parts. Okay, but when you look at the degree at the left side of the equation, you can see that, sorry, the coefficient of s squared, there's no s square here, so at the left side, so it means that the coefficient of s squared is 0. So it means 0 should be equal to a plus b. This implies that what, our b is equal to negative a, and that should be equal to negative 1 over 5. Okay, so b is equal to negative 1 over 5. Okay, now let's continue with our c. Obviously, I hope you can see c. Okay, c is 0, but let's show it. Okay, now if I have c, comparing the coefficient on the left and right, you see that there is the coefficient of x at the left is 0, and that of the right is what, c. So it means c is what, 0. So you come and put it here in the equation back. You put everything in the equation back. Okay, so the whole of this will give you a is 1 over 5. Okay, so if I put 1 over 5 at the numerator, we'll definitely get 1 over 5x. Okay, this I want you to go and prove it. Then plus negative, the b is what, negative 1 over 5, right? And our c is 0. Okay, so plus let me write it first. Negative 1 over 5 x plus 0 all over s squared plus 5. Okay, now this is what we've gotten. Alright, so looking at this is the same as 1 over 5 x and minus, okay, we got a minus 1 over 5x at the top there, then x over 5 into brackets s squared plus 5. This is from basic simplification in fractions. Okay, so like I said, always try to make sure your basics are with you. Okay, so the whole of this integral has been transformed into this. Okay, so let's rewrite our integral again. Okay, so now the whole of this integral has transformed into 1 over 5x minus x over 5 into s squared plus 5. Okay, alright, then let's look at how we integrate this. We said in our previous and basic definitions of integral that this is the same as integral of 1 over 5 x, okay, dx. Now the sign separating them is minus, so I can put it back and then just get x over 5 into s squared plus 5 dx. Okay, so I integrate it separately, then after that I add them. Okay, so the integral of 1 over 5x dx is the same as what 1 over 5 out, okay, integral of 1 over x dx. Now this is true because 1 over 5 is just a constant, okay, so this is equal to 1 over 5, then the integral of 1 over x, we just wrote it here at the top here. So if you could remember, I first defined this, okay, then this is the same as ln of x, okay, integral of 1 over x is ln of x, then plus c. That is for the first side, okay. Now let's keep it in mind, okay, let's put it somewhere and get alright. So we are done with the first part and we had this, okay. Now the second part is integral of x over 5 s squared plus 5 dx. Now this is the same as integral of 1 over 5 times x over s squared plus 5 dx, okay. And so this should give me 1 over 5 out, the integral of x over s squared plus 5 dx, okay. Now you can use substitution here because looking at the numerator and denominator, okay, you can call from our first substitution method that we did, you can call our g of x to be x and our f of x to be what, s squared, okay, plus 5. The reason I'm not writing 1 over s squared plus 5 is because if I do that, then differential will be tedious, okay. So if I let something equals the f of x, you can see that after differentiating this side, we'll get a power like this one and it will come and cancel, okay. So let's try to do that and see. So now if I let u be equal to s squared plus 5, okay, then it means that the u dx should give me 2x, and this means that my dx will actually be equal to du over 2x, okay. Now that is it, okay. So let's keep this in mind, come and erase some parts and we'll continue from there. Now this is equal to 1 over 5, then integral of x over u, then du over 2x, right, from what we defined for dx. Now the whole of this will give us 1 over 5 integral of 1 over u du. Why? Because 1 over 2u, okay, there is a 2u here, okay, 1 over 2u du, because this s can take this s out and it will be done, okay. So now everything is transformed to u, but this doesn't look so nice, okay, so we can do something to the integral again. So this can give us 1 over 5, then we can factor 1 over 2 out from the integral sign, okay, the integral of 1 over u du. Okay, so this will give us 1 over 10, okay, integral of 1 over u du. So now we are good to go, because everything is sent back to this definition. Okay, all right, let's look at it. So now we have 1 over 10 integral of 1 over u du, and this will be equal to 1 over 10 ln of what? U plus c, and our u is s squared plus 5, so the whole of this will give us 1 over 10 ln of s squared plus 5 plus c. So the only thing we have to do is that after getting this side, this one and this one, you just come and put them back in our original integral. Mind you, the integral was like this. Now mind you, this is how we got the partial fraction to be. Okay, this side. And now we said this is equal to the integral of 1 over 5x. Sorry. 1 over 5x. Then let's write our ds first. Okay, dx, then minus integral of 1 over 5 s squared plus 5 all dx. Okay, and this is what we had for integral of 1 over 5s, and this is what we had for integral of the, so this should give us 1 over 5 ln x minus 1 over 10 ln of s squared plus 5 all plus a capital C, because this constant and this constant are not the same, so when you subtract you definitely get a different constant. Okay, that is why you should know they are not the same. So the final answer is like this. Okay, it's like this, 1 over 5 then ln of x minus 1 over 10 then ln of s squared plus 5 all plus c. So this is it for solution to partial fractions integrals. Okay, so if you get a partial fraction, or if you get an integral that you think you can't solve, then apply your partial fractions. Okay.